over to you, Tom.
Okay, well, first of all, I'd like to thank the Institute of Structural Engineers in Dubai for allowing us to present today. And a special thank goes to you and Abdullah. Thank you very much for letting us present. Our presentation is entitled Sustainable Personalized Solutions for Industrial Floor Slabs. So if you can push the buttons, Etienne. So we'll give a brief introduction to Twintec. Twintec are an international company. We work across 5 continents. We have 12 local presence, which entitles to work in 30 countries around the world. So for instance, here in Dubai, we look after, our office is based in Dubai, but we look after Bahrain, Oman, Kuwait, and Qatar. The group turnover is 200 million euros. And we design and build more than 4 million square meters of industrial flooring per year. To date, we have installed 3.1 million square meters in the GCC countries. And Twintec, the company, has over 35 years experience in designing and the construction of slabs. We take total responsibility. So we design, build and guarantee, and I will go into that a little bit deeper later on. And because we've been around for 35 years and we know what we're doing, we have the best supply chain partners. So we use the best steel fibers, dry shake hardeners, cedar curing agents, and steel armored joints. So we know what's best to use for industrial flooring. So here you can see a map of the world where we have been involved in installing concrete floor slabs. But what we've got to stress, we will work anywhere in the world. So for instance, we're going to be doing our first project in Kenya. We don't have an office there, but we're actually design and install in Kenya and in I can't remember where it is now. In Kenya, where else have we done? Yes, anyway, we will install slabs anywhere in the world, even where we don't have an office. Okay. Okay, in the UAE, this is a partial reference list. So our largest project in the UAE is an IKEA distribution warehouse in Dubai South, which is nearly 100,000 square meters, where we were installing panels, 2,500 square meters a day, 6 days a week. Our oldest reference in Dubai is the Caterpillar warehouse, where it's 40,000, just over 40,000 square meters. And that particular slab is 12 years old. Our oldest slab in the Middle East is a Panda warehouse, which was 90,000 square meters, and it is over 15 years old. So we're not new to the Middle East. We've been around for quite a while. So our vision and core values. Twintec's vision is to provide a personal product through a total offer concept with a high level of performance, environmental sustainability, and aesthetics worldwide. So social, we promote strong human values, unite between our employees, stakeholders, respect for all. We are proud of the diversity within the Twintec group and the dynamic environment this creates. So basically, we would liken Twintec as a large family. Respect runs throughout all levels of the company. And people enjoy working for Twintec, and we retain our employees for a long time. So for instance, Ruth has been working with Twintec 23 years, Etienne 18 years, and myself 15 years. So it's an enjoyable place to work. So the environment, our activities have an impact on the world we live in. We embrace our social responsibilities. and are committed to developing sustainable solutions for our current and future generations. Our owner, Bruno Lazari, is extremely passionate with regard to protecting the environment. He urges and encourages our research and development team to produce solutions that reduce carbon emissions. And Etienne will, obviously, that's the main body of our presentation, and Etienne will talk about that later. Knowledge. The value of our company lies in the skills, experience, and knowledge of our employees. Knowledge is the greatest asset to man that man possesses. Twintec is committed to respecting, embracing, and developing for the knowledge of all. So knowledge and skills of our employees run right through the company, whether that be senior management, commercial and technical managers, production managers, and our skilled labour force. We're a dynamic company who are not afraid of change, and hence we not only rely on the old skill workforce, but we will bring in new blood from time to time into the company. So Twintec have a total offer concept. So design, our in-house engineers who are based in Belgium and Holland, we will gather all the relevant information and clients' requirements for a project. We will give value engineering and personalized design solutions. We also build and install slabs. So we use our own in-house skilled labor. We don't use subcontractors. And this skilled labor, a lot of these guys have been working for Twintec for over 20 years. So the good news for you as a client and a consultant is that if some of our guys build today, 5 years down the road, it's probably going to be the same people. So we design, we also install. Guarantee. So we give warranties for our slab. We also give PI and product liability insurance. So the product liability insurance is very unique to Twintec. We don't believe any other flooring contractor gives this type of insurance. So if the floor totally fails, the insurance company will take the client from the building, pay for removing and replacing the slab, and bring the client back. The good news is we haven't had to use this, which is very good. So we feel it's vitally important for you as consultant engineers and your clients that we take full responsibility. So we take the risk away from you as engineers and the risk away from your client and give you a total offer concept. Okay, we have 4 main personalized solutions. So our free plan slab is a large bay jointless steel fiber reinforced slab. And the free plan slabs would be tend to lay to a standard tolerance of FM2. Twin plan, it gives the same results. So it's large bay jointless, up to 40 meters by 40 meters with no saw cuts. But in this case, the twin plan, we lay very flat floors. So for V&A forklifts, we'll lay DM1, DM2 floors. Or for very flat free movement forklifts, we'll lay FM1 floors. Twintec Ultimate, this is a combination of steel fibers and top reinforcement. This is where we produce completely seamless slabs. So these slabs have no joints that open, so no expansion joints, no contraction joints, no saw cuts, completely seamless. Twintec Structural, these are for very heavy loaded slabs and generally for carrying the loads of buildings or, for instance, for clad rack buildings. So very high loads, and this slab will be a combination of steel fibers and steel reinforcement. So for all these solutions, we can provide Twintec Eco. So the option is available for all the solutions, giving an environmental sustainable slabs. And this is the main body of our presentation, and Etienne will go into that in detail. So just on the top left, we have a very large sorting facility for an e-fulfillment company. And this is a free plan slab, large bay jointless, joints up to 40 meters apart with no saw cuts. And this was laid to FM2. On the top right, we have a twin plan slab, which is for V&A forklifts, and this happens to be a DM2 slab. Again, large bay jointless. Bottom left, we have cold store, and the bottom right, we have marshalling areas. But what we would say is people see us as just building warehouses. If there's a large expanse on concrete, we can build hangars, we can get involved in hangars, container terminals, exhibition halls, factories, and of course warehousing. So anywhere you've got a large expanse of concrete, Twintec can get involved. So hence our presentation's Twintec approach to sustainability. And this is where a much smarter man than me will take over, Etienne.
Thank you very much, Tom. So good evening to everyone. So now we are going to enter a little bit more into detail, as Tom mentioned, into the sustainability approach of our company. So I think it was quite clear that our company is really involved now in a process of developing internally and externally green and environmental sustainable solutions and behaving of the company. So this is affecting all the parts of our group, not only the people working on site, but there will be also a lot of investment and work done on different aspects, like minimizing any waste, protecting natural resources, taking energy efficient initiatives, and thinking really in the way of buying cleaner products to include into our production. So every component, every people in the company will have to think a bit greener and will have to participate to this effort to go towards a more sustainable product and results. Of course, this will, in our business, is concerning a lot of parts of the company group. Starting from the purchasing of all the materials that will apply on site, the labor force that will place the concrete, salespeople, research people. So everyone is really trying to move in the same direction today. So this chart is showing a little bit what are the impacts on the concrete flooring, industrial concrete flooring. Mainly what you can see within this black rectangle. So it's starting from the acquisition of the correct raw materials. This will have an impact on our carbon imprint. The choice of every product, ranging from the cement, the aggregates, all the chemical additives that we will put in the concrete, all the reinforcement that we will use to put in our concrete slab. And afterwards, there will be the process of production. So for the concrete mixing, in which we can add, as I say, different type of additives before laying the concrete. And the placement of concrete on site, of course, will induce many workers, many machine equipment. So all of that can participate also to the emission of CO2 in the environment. So all of that is, of course, linked with transportation, energy needed to produce and extract the materials, for example, as well as to produce the floor in itself. Outside of our scope, of course, there are other aspects. The first is the input of these raw materials into our working exercise. And after the floor is done, of course, there will be other aspects that could influence the carbon imprint of the concrete floor. Is first the maintenance of the floor, and we are really keen to try to give the floor that will minimize as much as possible the need for maintenance. We know that concrete flooring can link to many problems that will affect the use of the floor, but also its maintenance. So we are really orientated to solve this problem. And last but not least, the possibility of one day having to remove and recycle our product. So all of this will be numbered with different values, the energy consumptions, the emission in the atmosphere, mainly CO2, dust emissions, all the waste that will be delivered, and in some aspect the noise effect in the environment. So the subject of this presentation is not to detail all of these, because we could spend hours, of course, to discuss about that, but mainly about our philosophy that for us the floor will need to be optimized in its design in order to reduce as much as possible this carbon imprint. So basically, by reducing the amount of materials needed, so by improving the design and optimizing to the sharpest option possible, and also going towards solutions that will guarantee a low maintenance for the lifetime of the industrial concrete. So let's start first on the design aspect, because it's one of the subject that will, of course, is quite particular to our industry and our company, as this design is handled completely inside our group. So as Tom mentioned, we have quite a long track experience of concrete floors, because of the people working in the company, the fact that we are present in many different countries, different cultures that are working, maybe approaching the product and the concrete floor in a different ways. So we had the chance, I would say, to gather all of this knowledge and information within our company, and we try now to use it really in a way to improve the quality and the environment ability of our product. For doing that, of course, we need to have a good knowledge of all the materials that we are using. So that's what you see in this picture showing laboratory research, mainly about the application of steel fibers and combination steel fibers and reinforcement in the concrete floors. But also we have developed a lot of tools and design optimization that internally will help us really to find always the sharpest solution possible to deliver to our clients. So for that, we have a group of engineers in the company that are working locally and centrally to serve all the entire group, taking care of most of the in-house designs, but also delivering advisory to our clients in order to always to find the best solution, but also the solution that is that is tuned to the expectation of the end user of the warehouse. So basically, our philosophy in product development is based on a kind of evolution of concrete floor design from what was done some years ago. So typically what we call the traditional concrete floor, which is a floor including induced socket joints. These socket joints are necessary to try to control the shrinkage contraction of the concrete and mobilize it in hopefully in straight lines. But we know that effectively this doesn't happen really like we would like to see. And today we try to get away from this technique in order to reduce the number of joints that you can see between these three little graphs. In fact, we know that in concrete floors, the majority of the problems are linked to the concrete shrinkage, the uncontrolled concrete shrinkage, and also the presence of joints. So it's in our view to reduce the number of joints, and you will see that by doing that, we can still improve the sustainability of the product by reducing the amount of concrete, for example, from the traditional solution to the right side solution, which is much more optimal. So coming back to the traditional concrete floor, you certainly know that we work for many years by using relatively light fabric, light reinforcement, or a small amount of fibers in concrete floors, and trying to mobilize all the shrinkage in specific lines, what we call the defined joints, defined fraction lines. Of course, this is relatively a simple way of seeing concrete design, but this will link to a huge quantity of joints in the floor. So to give you an example, for a surface area of 1,000 square meter, we have approximately 300 linear meter of sound joints. And if you have any experience with industrial warehouses, you know that these joints are causing many problems for the user for different reasons, because the joints are starting to curl, so they are moving them with a differential shrinkage within the concrete slab. They are starting to rock when there is a lot of traffic over it. And at the end, we could see a lot of spalling, delamination problems along these joints because they are not really protected. From our estimation, we think that there are about 20% of the floor surface which is suspected to be damaged in this type of solution, if we consider that an area of 300 mil either side of any joint is prone to deterioration. And of course, we need to rely on load transfer within these joints, which is sometimes very difficult because we have a very small amount of reinforcement going from one slab to the other. The other aspect of this is when the user will start to the operation of warehousing within its building, we have the much more risk of having point loads, wheel loads going very close to these joints. So that's why generally the design of the floor is relatively thick in order to be designed properly for this critical position of loads. So the first evolution and first step we developed was to try to increase the distance between the joints in large bay panels. So we did that progressively, and now we can produce panel size of 30 to 40 meters Generally, this is limited by the quantity of concrete available in one day, but also by the risk that these joints will accumulate all the movement and will open obviously too much for the operation of the construction joints. So for that, we are using more reinforcement. It could be added steel reinforcement, rebars or mesh, or most generally a relatively high quantity of high performance fibers. We will talk a bit later about the product and the fibers themselves. So for 1,000 square meter, now from 300 linear meter of joints, we drop down to 50 meters only. These joints are fully protected because they have an armor protection, and they are only covering more or less 3% of the concrete surface. So we are limiting really the risk with this type of product, but the joints are still existing. And as I mentioned before, they will open more than a conventional socket joints because they accumulate much more movement over long distance. So they could open of 10, 15, sometimes 20 millimeter is in the worst case. And that's why these joints need to be really well protected and with a system that will guarantee a perfect load transfer. But that's also the reason why some new joints has been developed in order to reduce all the aspect of dynamic and fatigue over the joint, especially when all the material handling equipment will circulate onto the floor permanently day and night. So the last step in this evolution is what we call the ultimate. And the ultimate is a floor which has virtually no joints because there will be construction joints, but these construction joints will be fully tied and no joints will open over the totality of the area that is covered by this type of floor. And to reach that, we will work with a combination of steel fibers and top reinforcement. The top reinforcement will guarantee the control of the surface cracking, and the fibers will be designed and dosed for to support the structural load that are acting onto the floor. What is a major interest in this type of floor is we can lay the floor a bit where we want. We can place the construction joint in the best position for production, because this joint will not be virtually working in the future. So there are not really aspect ratio of panels to respect. We can guarantee the crack control by using sufficient amount of steel close to the top surface. And as we are get rid of any joint that can open, of course, we have no more problem of no more influence, I would say, on the use of vehicles onto the floor. The flatness will be guaranteed in the long term, especially along the perimeter and the edge. And this floor can also be done on different types of foundation, like slab on ground or slab on improved ground, or even slabs on piles. So effectively, it's really the most advanced product, which is in our range of products. And effectively, this can be really optimized in terms of concrete depth to reduce the amount of materials delivered and placed on site. And to reach this type of design, of course, we need to work with more advanced design methodology, and I will mainly noticed that all the ultimate floors are designed thanks to a non-linear finite element software in which we can effectively model the presence of fiber and reinforcement and use them together in order to optimize and guarantee the highest performance floor for the minimal thickness. So this software allows to design many different type of floor and load condition and support condition for different sorts of floor, and of course according to many different standards. Today, of course, we are confronted to multiple standards through the world, generally European, American, or Europe, more international codes. All of these can be applied and considered in our design tools. So we talked about the design aspect, so trying to reduce and minimize and optimize the floor design. The second aspect will be the material, so we can work to get a more sustainable product by working individually on every component of the floor. So in a floor, mainly we have concrete. So we are working. Majority of the materials that we use is concrete at a level of more or less 90%. The rest will be reinforcement and some other products. So as the majority of the product is concrete at a level of 90%, and this, as we know, will be a high product that will consume quite a lot of CO2. It's very, very important to try to reduce, to minimize the depth of the concrete slab. And again, this can be done by doing a design exercise, trying to reduce the quantity of concrete and cement that would be placed in the floor. Also, there are some other aspects that could be looked at, is the possibility of replacing the cement that are giving the highest carbon imprint. But I will talk just after this slide about this aspect. We could use also recycled aggregates, which is done in some application with concrete, but at this stage we have not really yet applied that on concrete flooring, as the shrinkage aspect and control of strength and quality of the concrete is still a very critical aspect of our product. So the rest of the 100% or the 10% remaining will be in majorities reinforcement that we will use in the concrete, and some other product like joints, slip membrane, polythene, dry shake hardener, and curing agent. With regard to the reinforcement, we could think to reduce the amount of steel, which is not always obvious if we want really to keep a high bearing and structural capacities to the floor. Of course, reducing the floor depth will require sometimes more volumic reinforcement within the concrete. What we try to do is to replace progressively the conventional heavy bars or mesh by steel fibers or even thinner fibers. So we have seen that effectively the quality of the steel can raise consequently if we are using very thin fibers. Traditionally, reinforcing bars has a strength of 400 to 500 MPa. If you compare that to steel fibers, the steel strengths can vary in between 1,000 and 2,000 MPa. So we have already an increase, a significant increase of the steel strength and the reinforcement strength. And now we have also the possibility of proposing repurposed steel fibers, which are coming from the a recycling process from end of life tires. But I will again come back a little bit further in the presentation about this project. So coming back to the concrete, everyone knows what's in the concrete. We have some water aggregates, sand, but basically what is causing the most pollution is, and it's well known, is the cement. And the cement actually is based on Portland product, and the Portland cement is recognized as being responsible for 8% of the total world CO2. So today there is a true involvement in the concrete industry, cement industry, to try to find some alternatives to the same one Portland cement. So there are different possibilities. Of course, we can use the blast furnace slags. We can use natural pozzolans or geopolymer. So there are a large number of choices to try to reduce the impact of this. So going straight forward on existing product now, standard in the concrete industry, we can simply go from a SEM1 to a SEM2 or even a SEM3 cement. Will already help quite a lot in terms of embodied carbon of the product. And of course, we can work on additive and admixtures that will be used in the concrete mix. We should anyway keep in mind that in concrete floors, as you can see on the right side pictures, we have some other aspects which are mainly workability of the concrete, to lay it on level and perfectly flat, reach the concrete strength to give the structural capacity to the floor, keep this its structural capacity. What we call the finishability. So we need to certainly to look at the fact that this floor will have to be finished. So we cannot have some delays in the setting of the concrete, or a fast setting could be also an issue too. And also the dry shake bonding is one of the most critical part of the finishing process. And last but not least, we want to have a product which is still controllable with its shrinkage. We could use a lot of admixture of replacement of product, of course, but we really focused on the fact that the concrete and the mix all together will guarantee the minimal shrinkage as much as possible. This slide shows a little bit in comparison between different concrete delivered concrete mix. So mix 1 is based on pure Portland SEM1 100%. The mix 2 is going a step forward using a SEM2 cement. So SEM2 has a Portland content in the order of there is a cement replacement of more or less 25%, and the SEM3, which I think is not applicable in the Middle East, is even replacing more Portland cement by GGBS up to a level of 65%. So what we can see is, of course, going from one cement to the other will quite significantly reduce the embodied carbon of the concrete mix. And as I mentioned before, we should keep in mind that the concrete is still 90% of the composition of a concrete floor. The second component of the floor is the reinforcement that can be rebars or welded mesh or steel fibers. And as I mentioned, the steel fibers has steel properties which are in between 2 and 5 times the quality of a conventional rebar. Or we can certainly work with a combination of the two. And this is one of the things that we are really promoting today in order to take the most benefit of every type of reinforcement where it's needed. And of course, this reinforcement will have to be optimized to guarantee that the floor can support its structural loads. To control cracking, that's one of the very important aspects of design. Of course, we will, as I mentioned, try to reduce the concrete depth in order to minimize the quantity of cement and concrete in the floor. And finally, avoid having excessive number of joints in the concrete floor. So one of the alternatives that we propose today is to repurpose some steel taken from end-of-life tires. Today, there are about 1.5 billion tires that are going to waste every year. So this huge amount of rubber contain also a very large part of steel, and this is not a simple quality of steel. It's a very high grade steel called steel cord, from which the quantity estimated is more or less 700,000 tons in a year. So all this steel is going to scrap if it's not used. And now we have the possibility and ability to separate the rubber from the steel after recycling of these tires, and to get it as clean as possible to mix and use it as a reinforcement. These little fibers, as you can see on the right side pictures, have a length in between 15 and 40 millimeters long. Their diameter in average is 0.25 millimeters. So it's relatively high number of fibers that will really participate to the reinforcing of the concrete mix. And generally, we will use this fiber in a replacement of a certain portion of the industrialized fiber that we generally use, which are a little bit longer in our concrete floor design. So what is the embodied carbon footprint of these type of fibers? You have quite a lot of numbers on this table. But what we need to keep in mind is this is coming from a pure waste. So this repurposed fiber will, of course, give a lot of benefit compared to a manufactured steel that will require very high temperature oven for the production of new steel or even recycled steel. So from, let's say, 100% embodied carbon footprint for manufactured steel fiber, this will drop to nearly zero, so 6% only, even if we include a part of transportation carbon footprint. Effectively, these fibers are still produced in some localized plant, but it's in the view of in our future to have them the most locally delivered. So that will be the additional step on the development of this product. So all to get together, if we replace, let's say, in in a cubic meter of concrete, 35 kilo of manufactured steel fibers by a mix of 25 and 10 of kilo of the AFT plus E fiber, which is the repurposed wire. We can already reduce the carbon footprint of 20, 25, even 30. We will aim to increase this number in the future. The last part of concrete floor is production, and it's not minimal because we know that we need quite a lot of manpower and equipment to produce a concrete floor. So we can also act to reduce all our to improve our sustainability on this aspect. So this will cover different part of the production. So the first is to the choice and purchase of the most sustainable products and try to find them locally to avoid any unnecessary transportation. The next step will be the use of very specific equipment. As you certainly know, we use high technology equipment now to lay floors with laser levels and things like that, which are mostly based on petrol engine or diesel engines. Today we have the possibility of developing, and we have started already that, to develop some fully electric machines in replacement of the traditional equipment. The people, of course, we, as I mentioned, our crew team are relatively large because they have to lay a lot of concrete in one day. But with the proper equipment, we can work with a minimum amount of labor on site, or keeping the same teams to deliver higher productivity. And that's also part of the optimization of our production. And of course, after production, there will be a lot of aspects that we do not always control, but that will help for the general sustainability again. So minimizing the maintenance is one of our aim, and trying to improve the flow in a way that will guarantee a long-lasting product without trouble. So I talked about the new developed equipment. This is an example of a laser screed machine which has been developed in-house in our company, which is completely electric, works on a battery, and can work for one day without any disruption. So that's really a very good improvement in the development of the equipment, not only in terms of CO2 emission, but also to improve the health of our workers that work around these equipment. So if we merge all together all these aspects, so the design, the materials, concrete and reinforcement, as well as the production impact, we can do a quick comparison of different products. And this was based on an experience in Europe, so maybe it will not fully apply to the Middle East, but is to give you more or less an idea of the percentage of reduction of CO2 that we could expect in concrete floors. So this was based on a platform of 27,000 square meters with relatively high loaded racks, 100 kilonewton per leg, concrete, and racking is relatively conventional. And if we compare the different solutions from traditional going through the free plan joint free flow to the ultimate seamless slab without any joint, you can see that the concrete slab depths can reduce. So we go from a 225 slab to a floor or more or less 200 millimeter, and going down to a 170 millimeter when we go fully ultimate seamless. Effectively, you can already see a clear reduction in concrete consumption, which helps in two things. First, to reduce, of course, the carbon imprint of the concrete, but also to improve the productivity in terms of slab production. So the first solution was based on a socket slab with a bottom mesh sewn every 6 meters. The second solution is a steel fiber reinforced slab with panel size of 30 meters by 30 meters. And the last option is seamless, of course, with a combination of 35 kilo of fibers and a top mesh. And the fibers were each time including the Eco option, so with a blend mix of manufactured fibers and repurposed fiber product. So this is just a little recall of what was shown before. So you can see already the reduction of joints in the floor, and you need to imagine that from the left to the right, the slab is going thinner and thinner, which helps also in terms of production, but also mainly in terms of sustainability. So all the products applied in this floor, of course, are relatively standard. We can imagine. What I will just pinpoint in this is the polyethylene membrane is maybe not necessary when we are doing a fully seamless floor. And obviously, for the two last options, we do not need to use very expensive and polluting diamond saw blades to cut the floor. So in terms of carbon footprint reduction, it's relatively straightforward when you compare a fully traditional solution with SEM1 Portland, which is used as a reference at 100%. You can see that going to an ultimate floor, so the floor that will propose the thinnest slab option, combined with the right mixed design of concrete and the right choice of fiber and reinforcement, we can reduce the carbon imprint of the floor of 35%, and I would estimate this to be increased in the next future when we will continue to improve our products. So I will pass on the talk to Tom for the last part of this presentation.
Okay, just to explain that Twintec. Let me see if I can get my video on. Sorry, I've just put my video on. If I can find it, there we go. Right, so just to explain. Oh dear, just trying to get the screen back up. Okay, just to explain, Twintec, our main focus is on new build, so we design and build new floors. But we also repair old floors. So the value of maintenance and refurbishment, the failure to maintain concrete floors and joints will ultimately lead to higher long-term cost and lower efficiency. This will also affect the carbon emissions because you have to do work to your floor. So the common problems we have with existing floors, if you just press the button, Etienne. So basically, very common problems. We have breakdown of beams, saw cuts, and expansion joints. And in the Middle East, I've been coming here for 9 years now. On the older floors, quite often you would see beams to the top of the floor with 2 isolation joints, and when the forklifts run over the beams, they break down. Unprotected expansion joints and unprotected saw cut joints. You also get surface damage, impact damage, and also we have problem with floor flatness or regularities where the floor is not installed flat enough to allow V&A forklifts to run. We also have dusty and dirty surfaces. You just move on. So basically, there are a number of ways that we can improve the life cost and sustainability value of the floor. Of course, when you've got a floor that's totally spent, the only way you can do it is replace the floor. So obviously, this has the highest carbon emissions. So you have to totally remove the floor and replace. And we've been involved in quite a few floor replacements. Then you can use bonded or unbonded screeds. So bonded screeds generally installed between 50 and 80 mil thick, so less carbon emissions. But the problem with bonded screeds, you have to follow exactly what's on the floor below. So you've got to follow the joints. So it's very rare that bonded screeds are successful. So you can again go with unbonded screeds, and generally speaking, you lay a polythene slip membrane, you ignore the joints below, and you install the slab anything between 120 and 150 thick. So sometimes floors are laid and they're not to the right flatness tolerance. So the only way that you can bring to that tolerance is by grinding methods. So to bring a bad floor to say a DM1 or DM2 floor, you have to use sophisticated laser grinders, which I believe there's only 2 or 3 people in the world who can actually grind floors to the correct flatness. Repairs to beams and joints. This is probably most of our refurbishing work is to these beams and the joints. So on the right-hand side, on the top right, you can see the beam has been damaged, the joint either side has been damaged, and we use a product called Twinflex, where we band over the beam and onto the existing floor. This produces a very smooth, very hard wearing, but slightly flexible surface, which doesn't break down with the forklifts. Where you've got very dirty floors and very old floors, we can microgrind and polish. And this produces a very hard wearing surface, but very light reflectant. So basically, quite often they can reduce their lighting, reducing their carbon emissions. So really, just to summarize, it's going slow. So to summarize, in summary, basically design optimization is the key to sustainability. So already Etienne has mentioned what we do is we try and optimize the slab thickness and the reinforcement used to achieve the lowest material consumption. We design using environmentally sustainable materials, which will give a reduction of embodied carbon footprint. So we'll be using repurposed steel fibers. We can also use cement replacement, so it's dependent on the materials. Design optimization will also reduce ongoing maintenance cost, and this can contribute to the facility's life cost and reduce carbon footprint. So what we're saying is, you as engineers, we believe that you should eliminate saw cuts, produce either large bay jointless slabs or seamless slabs. By doing this, you will greatly reduce your maintenance cost of the building, hence reducing your carbon footprint. On the final slide of the presentation, quite often in the Middle East now, consultants are using TR34 from the Concrete Society, and the 3rd edition states an ideal floor would be perfectly flat, and have no joints. So of course, what Etienne does, we design floors with either very few joints, which are ultimately protected, or no joints. So basically that ends the presentation, and we would like, I'm sure Declan will let us open the floor question and answering session. And once again, I would like to thank the Institute of Structural Engineers for letting to present.
Okay, and thank you very much, Tom and Etienne. Very interesting talk, and you can see how you know, with the correct research and development and the optimization of the materials, that you can really reduce the carbon footprint, and with less materials there should also be a follow-on saving in cost. So that's great. If anyone has any questions, please put them in the chat box. I think we may have one or two here. Okay, and Nabil has just asked, what's the flexibility with regarding putting in new holes or openings in a slab, maybe for drainage or column or something? Are there any special precautions that would be required in that instance?
If you want that in, I'll answer that. So basically, it's really no different to a traditional slab. Yes, there's precautions to take, but I suppose an answer, if the slab, the large bay joint of the slab has reached most of its shrinkage, there's actually no problem to cut holes in the slab. Obviously, we would advise people the best way to do that. But for instance, most recently, we installed a very large slab, which is about 2,000 square meters, and the client wanted to put on in very, very heavy mezzanines, which meant he had to cut holes in the slab that were 1.4 meters by 1.4 meters, and also bigger openings, which were 11 meters by 6 meters. So we give them a methodology for cutting it into those slabs. So to answer your question, it doesn't really cause a problem. We would need to have input to advise on how to cut the slab.
Okay, thank you. The next question is from Mohammed. Can you use Twintec steel fibers with ordinary ready-mix concrete?
Yeah, I will answer maybe to this one. I suppose the name Twincon was the previous name of the repurposed fiber from tires. Twincon fiber and the AFT e-fiber. We have done some research with this fiber only, but it was mostly for our interest in the product. We could use it as the only reinforcement, of course. We have not experienced it on large scale, but that's a possibility. The question is, this fiber is very thin and are very high numbers. So if we use increased dosage of this fiber, the quantity of the fiber and the network of fibers will require to work with a specific mix of design with very small aggregates, which is not really compatible with a controlled shrinkage. So it's not really in our view at this stage.
So what you're saying is, Etienne, that our repurposed fiber has to be used in combination with other manufactured fibers.
Exactly.
That's correct, isn't it?
That's correct.
Yeah.
Okay, thank you. David is asking, it's regarding a design comparison. How do your floors compare with post-tensioned slabs on grade?
Do you want to answer, Tom? Or?
No, you go and I'll add to it. I suppose really we should be answering the question with a question. Compared to what? Do you compare with carbon emissions, or you compare with loading requirements or your current crack control. I suppose, you know, what can be a difficult question.
Obviously, the post-tension slabs will require to place some cables first. So you will need to pump the concrete. So in terms of production, it's a completely different product, of course. So we do not have a large experience with post-tension floors. We never investigated yet on this method of placement for different reasons, because we want to work as fast as possible with the highest productivity. The post-tensioning will also prevent, as it was asked in the first question, to dig some holes into the slab, because you will hit directly all the cables. And we find that the steel fiber product is still the most valuable in terms of speed and efficiency to produce joint-free flow without any questioning.
Yeah, Eddie, and that's a very good point, that obviously if you're going to cut openings in the slab, you can't do it in the post-tension slab because you cut.
Yes, thank you. I just have a couple of questions. After you finish your work and you leave the client with the nice new slab, some shrinkage will continue, and you may get a phone call from the client saying that they've seen some cracks in the slab. That may not be structural, but how do you deal with those aftercare questions that you may get from the client?
What I would say is a couple of things that it's very important that we educate the client beforehand. So he has to be aware that obviously if you're building a 40 meter by 40 meter panel, your actual steel armor joints will open to a certain size. So he has to be aware of that. As regards to cracks in concrete, of course, we try to ensure that do a number of things to prevent cracking, so that the design right. There's no, we use the right curing. We ask for the building to be enclosed. We'll do everything in our power to prevent cracking. And with the ultimate system, we can actually guarantee a minimum crack width. So basically, if the client is very, very worried about cracks, we can use the top reinforcement to control that cracking and give them a maximum guaranteed crack width. Within our defects policy, we clearly tell people how we deal with cracks. You as engineers know that the concrete tends to crack. But if you have a crack that is 0.3 of a millimeter wide, or 0.2 of a millimeter wide, will that cause any problem to the operation of the building? The answer is no. If you're a crack that is a millimeter wide and a little bit more, you get constant wear and tear of forklifts. Well, yes, the crack might fall and affect the operation eventually. I don't know if that answers your question.
No, that's good. Thank you. And also just with the when you're power floating the fiber reinforced concrete slab, are there any issues with getting a smooth surface at the top? Do the fibers stay below the surface?
Well, we use a dry shake hardener to suppress the fiber. We would not totally 100% guarantee that you wouldn't see a fiber on the top. But if you or some of your colleagues want to come and see floors, quite often it's very difficult to actually find fiber. And you might be asking the question, did they actually put fibers in the concrete? So you've got to remember that in some cases, there's 130,000 bits of fiber per cubic meter. In most cases, we don't have complaints with fiber show. Probably 99% of the time, we don't have any complaints about fiber show. Will you have the odd fiber shown on the surface?
Yeah.
It will be hard to find.
Yeah. Okay. Okay. Thank you. Mohammed has just asked, how can we be aligned with the launch of new non-metallic solutions?
I'll do a bit of an answer, and maybe Eddie can answer better than me. In past life, synthetic fibers and polypropylene fibers, and Eddie can correct me if I'm wrong, but these fibers don't add any real structural strength. So when you're designing, you've got design as plain concrete. So we tend not to use synthetic fibers, although we have used them in the past. Do you want to add to that, Etienne, if I said anything incorrectly?
No, you are perfectly right. The synthetic fibers have a stiffness modulus which is generally lower than the one of concrete. So the reinforcing effect is usually relatively limited. There are some new macrofibers that could bring a little bit better effect, but it's usually relatively limited in time. When the concrete is relatively soft and fresh, it's working fine. We do not see that as a real reinforcement for very high structural loads. And as we explained, we try always to increase the reinforcing effect of our steel or reinforcement in order to reduce the depth of the slab, and that's really an aim for in our products.
Okay, thank you very much. I noticed one picture of a cold store where you probably have temperatures of -20 or something. Were there any special design considerations for those slabs?
We've done many cold stores and freezer rooms, and the only consideration, well, there's two considerations. We want to make sure the insulation has got the right bearing capacity to carry the slab and the loads. And the only other thing that we probably will reduce the panel size. We wouldn't have a 40 meter by 40 meter panel. We would reduce to 30 by 30 because the joint would tend to open too much. But obviously, if you build an ultimate slab, there are no joints that open. So we wouldn't do anything if it's different if it's an ultimate slab. So for cold stores, they're the two main things that we would consider.
All right. Okay. Thank you. I think that's it. We've unless anyone has any other questions to raise. So yeah, on behalf of the iStruct, I'd like to thank Etienne and Tom and Ruth very much for providing us with this very interesting topic. So thank you very much, and I'm sure we'll